This is still 14.3. Okay, so we talked about comparing K values to determine if something is relatively strong or weak. Okay, acid with a bigger Ka value is a stronger acid compared to something with a smaller value, right? Okay. Does the same logic apply for bases? Yes. Yeah. The larger the Kb value compared to something else, okay, is the stronger base. I want to talk just about acids from a molecular, actual molecule point of view, and talk about why something would be strong or weak. You know, all we usually tell you guys is to memorize what? Memorize the 6 strong acids, right? If it's not one of the 6 strong acids, then it's weak. Okay. So, right, let's pretend this is HCl. Okay, right. And I tell you guys that that's a strong acid. But then I tell you guys that HF is what? Not a strong acid. HF. It's not a strong acid. Let's pretend this is F. Why? Like, they're literally like almost the same thing, aren't they? Why? Here's why. We're thinking about acid strength from a molecular point of view here, okay? I want to look at acids both as binary. This is how we learned how to name them, right? Binary acids and then oxyacids. Okay, so if you want to wait to write this word till later, that's fine. These are the 2 classes of acids we look at. Binary acid means what kind? Things like HF and HCl and HBr and HI, right? Okay. This is those acids that form from group 7A. We know those are the halogens. Yes, right? Other binary acids. What does it mean to be an acid? Gives away a proton. So anything that technically could give away a proton can be an acid. Okay. So let's look at some group 6A binary acids. Does anybody in here who had me for Gen Chem 1? Does anybody remember the name of the elements in group 6A? Chalcogens. Chalcogens, yes. That's an old name for these elements in group 6A, chalcogens. I don't expect you don't have to remember that. You don't have to remember that. Okay. I like to it's based on okay, I can't remember now if it's Latin or Greek root, but this prefix means suffocation. Right? Okay. And so it's mainly because elements with sulfur in it give off gases that make you like choke and suffocate. That's why they're called that. What would be under H2O? What's the next element? H2S, H2SE.
Why is it H2?
Okay, because remember when acids come together, okay, we think of their formulas as coming together from ions. And every non-metal in group 6A are what charge when they're ions? -2. So that's why. So they're paired up with this H+, so it's got to have 2 H's for every 1 chalcogen ion. Okay. Okay, let's stop there. Okay. So when we look at binary acids, here's how we can judge without K value. So this is really what I'm trying to teach you, is how can you tell me which is the stronger acid if I don't give you any numbers to look at? That'll play a part in some of it, yes. Let's look at the first trend. So I said, I've taught you guys that this is a strong acid, this is a strong acid, this is a strong acid. These are 3 of the 6 you're supposed to know, but this is not. Water, not a strong acid, you guys. This is a stronger acid than this one. This is stronger than this. Here's our trend. When you're looking down a group, the size of the atoms is increasing. Okay. Chlorine is bigger than chlorine. Bromine is bigger than chlorine. Iodine is bigger than bromine. All okay. Size is getting bigger. Okay. What that means is that bond between the hydrogen, our proton, the bond between our proton and whatever the other atom is. Okay. This bond is weaker let's look at these 3 little illustrations, okay? Okay. Let's just look at these 3. I'm telling you that when this is small, it hangs on really tightly to that H. There's a whole lot of attraction right here. As it gets bigger, this is not as tightly held of a bond. Why? Because this is a big old fat atom. Okay, big old fat guy. Okay, this H is a little easier to come off. Get to something even bigger. This H is real easy to come off. The bigger it is, the weaker this bond is, the easier the H plus comes off. And isn't that what makes something an acid? When the H plus comes off, right? H plus comes off, acid. The weaker this bond, the stronger the acid. Because this bond is weak and it's more willing for the H plus to get donated away. Much easier to dissociate. That is exactly right, Joseph. When this is real weak, it is real easy to dissociate. So what's stronger? H2S or H2O? H2S. Why? It's going down. Bigger atom. Okay, what if I want to compare left to right? Okay, if I'm going to compare left to right, then what I think about is the electronegativity. Okay, going left to right, we see what's happening to electronegativity. Electronegativity increases going left to right. Okay. So when that is happening, what that means is, again, this bond is getting weaker. When that electronegativity increases, we get more polar, right? More pull in one way or the other, yes? All of that. Well, now I got a color scheme going, so I got to stick with it. Okay, here we go. Again, this bond is weaker. And so what does that result? What does that mean? Acid is stronger. Think about it. Compare H2O to HF. H2O to HF, guys, which of these is the stronger acid? I promise you it's this. Promise you it's this. Compare H2S to HCl. Which of these is the stronger acid? Absolutely HCl. There's the trend. Okay. Why? Electronegativity increases, blah, blah, easier to ionize. That's really the answer. Okay. For oxyacids, Veronica, do I need to move? Okay. How do I want to talk about this? Because I'm not trying to get too into the weeds with this. Okay. Oxyacids are going to be things like, right? What are they? They have oxygen in them, right? These are two strong acids, yes? Can we recognize those as strong acids? Okay. These are just two examples, right? Okay, just two examples. You can also have this acid, right? You can have this acid, right? Now, are these strong acids? Only those two are part of the 6 strong, right? Well, what's the difference between this and this? Why can't this be strong? That's what I want us for now to just look at. Let's know this, okay? There's not as many oxygens, and that means not as strong of an acid. Okay?
Wait, which ones are those?
The ones with fewer oxygens means lesser acid strength.
But they have the same amount of oxygen.
I'm comparing these two.
Oh, okay.
Right? These two. This is strong. We all should know this is strong. Why is this one weak? I'm saying let's just think for right now, let's just say it doesn't have as many oxygens, and that's making it weaker. Okay, let's just say that for now. So, right, I was really comparing these two, and then I'm comparing these two. Okay, less oxygens means weaker acid. But you got to be comparing something similar. Like, can I compare this and this? No. And I can't compare that and that. No. If we're talking about how many oxygens, you need to be looking at the similar acids. Okay. We can also think with oxyacids, we can also compare differences in electronegativity as well. Okay, that applies to oxyacids as well. Okay. This is number 1 on our in class. New part 2 in class. Part 2, right? Part 2 in class. Yeah, before Tuesday is an interesting question, but I think so. She said, "Are we gonna be able to finish this chapter before Tuesday?" Basically, because that's when we're supposed to have our test. And I said, "I think so. I hope so. I don't know. I didn't realize that Crawfish Day was right in the middle of all of this acid-base stuff." Okay. Yeah, I'm not worried about any of this stuff. I'm not worried about any of that. I'm not worried about any of that. Okay, here, let's just look at this. Okay, I want us to not forget a couple of things that we've already discussed. Okay, so if you look at this very first one, here's two species listed, H2S and HS minus. Okay, tell me which one is the stronger acid. Isn't that what I asked? Give the stronger acid. Okay, so what's the relationship between these two things that I have written right here? What is their relationship? Do they have a relationship to each other? They do indeed have a relationship. They are known as conjugates. They are indeed conjugate pairs. So what is the conjugate acid and what is the conjugate base here? Which one is giving away? This gave away to turn into this. Good. Okay. So this is our conjugate acid. Oh, I guess here. That's our acid and this is our conjugate base. We'll say it that way. Yeah. Guys, which one of these then is the stronger acid? H2S. Excellent. Good job. Okay. That's a no-brainer, I hope. No. I'm going to put it on the test and everybody's going to get it wrong. So we'll see. Okay. Okay. What about these two pairs? Okay. H2SO3. So sulfurous acid. And then H2SeO3. I guess that would be selenious acid. Okay. Well. Ooh, okay. So you're saying this one and you're saying this one? You're saying this one too? What? Okay, that's why I had to do this to you guys. No. That's further down. Only applies to binary acids. And this is an oxyacid because of the oxygens. Okay. So you either, for oxyacids, can think about which has more. But they got to be, but these both, okay, that doesn't work here. Or we can think about electronegativity. Which element, sulfur or selenium, is more electronegative? Which one is getting closer to fluorine? Sulfur. Sulfur is more electronegative. So which is the stronger acid? Yes, correct. Tricky, Miss Poe. I know that's going to be, I'm definitely putting that on the test now. Definitely putting that on the test now, for sure.
Yeah, it should be on this next test. It should be like
50 points now? This one question? 50 points, everybody? These exact examples? Okay. And just these two and no other options to screw you up? Okay. Deal. Bet, as you kids say.
Trying to get savvy over there?
I'm a, oh God, what was it Carolee called? She called me something. I'm not gonna be able to think of the word now. It was some nonsense word, and I was like, what does that mean? What does that mean? She's like, basically it means a lot, and then she says Mr. But the result of it all was I'm cringe, and I was like, cringe you back into the food. Sometimes that child. She needs a whooping. I didn't whoop her enough. That's the problem. I didn't get after her with that chancla. You know what I'm saying? Okay. The chancla, the Mexican mom sandal. I hope. No, because I know that one. I hope that in this pairing you can just recognize that HBr is one of the 6 strong acids you're supposed to know.
Yeah, sure.
Okay.
Definitely gonna be that no part. Yeah, definitely gonna be that no part. She but she just talked about it in group 7A.
Classic strong acid.
I don't remember that.
Classic.
All that shit. Don't be in the
But if we were really trying to think about why that's a strong acid, why is it a strong acid and this is not? Why? Because bromine is more electronegative than selenium. So this bond is a weaker bond and it dissociates more easily.
Wait, but I thought you said
What up?
isn't Fe closer to chlorine than bromine?
Dude,
Going
No.
side to side?
no, it is not. Bromine is closer. Bromine is closer.
No.
It's 2 under it.
And then, no, you're looking at beryllium. 4 is beryllium.
Is she looking at the wrong damn element?
No, I'm not. We are. It's 2 underneath.
It's 2
I
underneath.
thought you were looking at it going side to side.
Compare selenium and bromine. Bromine is closer to fluorine than selenium is, so bromine is more electronegative.
So we need to go up 2 over 1.
Selenium has to go up 2 and then over 1 to get closer to fluorine.
Oh, so it doesn't have to go in order side to side.
Straight shot.
Okay.
Okay, we're fine. We are all just fine now. I thought you were looking at beryllium when you said that. I was like, no. Guys, okay, come on. Y'all are never we're never gonna be done. We're never gonna finish today. We're never gonna finish. Come on. Whew. I'm gonna end up having to record videos and make y'all watch them. Yes, that's what's about to happen. Okay, which one?
First one is
More
more H's.
O's. More oxygens.
Very, uncreative with these answers. They're all,
The first one listed.
I mean, you can also look at the last.
Yeah, what about the last one? Don't you guys love when on a test you get like E like 4 times in a row and you're like, something's not right. Something's not right.
It was all one letter and then the last question was a different one.
That's mean. And which one is?
H2S.
Now why is H2S?
Because we know that H2S is weaker acid.
Why is H2S a stronger acid than H2O? This is comparing size. This is binary acid, and I can compare size. S is bigger. Bigger, weaker bond, stronger acid. Okay, now I'm doing out of order. I'm sorry. I decided I want to save this topic to talk about next time. So we're actually going in section order. I sometimes do these questions in out of order. So we're actually going in section order, but so we're gonna skip questions 2 and 3 for today. Okay. We're going to question 4 and we're going to a new section. Still the same slides. So normally I actually try to talk about section 14.5 right now, but I've decided I'm going to save that. I want to talk about I want to talk about section 14.4. I want to go in order. So we're going to come back to polyprotic acids tomorrow. 4.3 is now finished. Yes. Okay. 14.3 is now finished. So let's look at 14. Oh yeah, there you go.
Yeah.
Okay. Okay, here we go. Let's talk about this. This is the last section I want to do today. So I've decided that we're not going to go to lab today. We're going to talk about this section and then we're going to be done for the day. Okay. Hydrolysis. We know what that means. What does that word hydrolysis mean? How does it interact with water? That's what it means. And what does the word salt mean? Yeah, that's what it means. You guys, we got to remember when chemists say the word salt, we do not mean only sodium chloride, right? We don't mean only sodium chloride. salt means any ionic compound. Okay. Ionic compounds are made of what? It's not a trick. What makes up ionic compounds? Ions, yes. Ionic compounds are made of ions, right? What are the ions? Cation and anion, right? Okay. So what I need you guys to recognize is that when we talk about acid-base reactions, right? Okay, so I'm not talking about acid hydrolysis right now, and I'm not talking about base hydrolysis right now. I'm talking about a good old-fashioned acid plus base makes, anybody remember? Water and a salt. Yes. Acid plus base makes water plus salt, or salt plus water, whatever way you want to say it, right? Okay. What was another word for these acid-base reactions that we would use? There's maybe a couple other words you could say, but there's one word in particular I'm looking for.
Never mind.
Not redox.
Synthesis?
No.
Decomposition?
No.
Single replacement?
No.
Double replacement?
Okay, so it follows a double displacement pattern, but that's still not the word I'm looking for. Hang on. Hang on. Okay, I'll put that up here. Follows double displacement. Guys, this is what we learned as a neutralization reaction. Yeah. Oh, okay. No. Okay. Nobody remember that. We called these neutralization reactions, right? Okay. We called them neutralization reactions. Let me write a couple up here. Okay. Start a couple. Here's very classic, right? HCl plus NaOH makes. What does it make? NaCl. Where did you get the Na and the Cl from? Okay. When we talk about double displacement, we said, oh, okay, we're going to swap our cation. We're going to swap the H plus is swapping places with the Na plus. That's what we're doing, right? Okay. So in my salt, my anion is coming from where? It comes from the acid, right? My anion in my salt comes from my acid, right? And where does my cation come from? Okay, my cation comes from my base. Guys, you got to know your ion charges. Okay. So this particular combination, okay, so here's my salt. It is indeed soluble, right? It fully dissolves in water. Okay. I made H2O as well. That's my liquid. Okay. Guys, this particular salt, sodium chloride, if I dissolve sodium chloride in water, I do indeed end up with a neutral solution. We should now know what I mean when I say neutral solution. What do I mean? No charge? Is that the best way to say that? No. What do I mean? If I say it's neutral, what does that mean? So pH is dead ass 7, right? Isn't that what we mean? What does that mean about the concentrations of hydronium ion and hydroxide ion in this solution? They're the same. If I say it's neutral, that means the amount of H3O plus in here and the amount of OH minus in here, dead ass equal. Okay. Let's see. Okay, so if this is neutral, I just put salt in there. If this is neutral, this indicator should turn it green. Okay, so let's see. Okay, actually, it's a little yellow because my water is probably not very pure. But let's pretend it's green. I mean, it was green initially. Okay, green. Everybody agree? It's green. It's green. It's green, guys. It's green. Okay. This is because sodium chloride is an example of a neutral salt. Okay. Sodium chloride is now what we can call a neutral salt. This is an example of a neutral salt. It contains inert cations and inert anions. Let's write that. Inert cations. What do I mean when I say inert? They do not react, is what I mean. Inert means does not react, okay? Inert cations are going to be ions like lithium, sodium, potassium, rubidium. Okay, so group 1A, right? Group 1A. Also, these ions should be inert. Calcium. Strontium. Barium. What am I writing here, you guys? These are the cations that are classically paired up with hydroxides and that are strong bases, right? These ions, these cations I was writing here, right? These inert cations are what are classically from our strong bases, right? Any of these paired with hydroxide is one of the strong bases. Right? Like those strong bases, any of these cations, okay? If they are in your salt, what am I telling you? They are inert, okay? They're not going to react. They're not going to do any other reaction. They're just floating in the water, okay? They're inert. Let's look at this anion. Okay, so again, I'm talking about a neutral salt, right? Meaning this salt, when it's dissolved in water, has a pH of 7. Yeah, it has a pH of 7. Very good. Okay. So I'm telling you that it's neutral if the cation is inert and if the anion is also inert, but I got a better way to think about this, okay? It's an inert anion. It is the conjugate base of a weak acid. Scratch. Of a strong acid. Okay. Sorry. An inert anion. Anions are what? The negatively charged things, right? Okay. An anion is inert if it's the conjugate base of a strong acid, like HCl. Isn't HCl one of our 6 strong acids? Sure. When HCl dissolves in water, what does it form?
Cl minus H3O.
Excellent, Loretta. Very good.
Can't mess that up.
Right? Strong acids in water, if this is the anion in the salt we are looking at, that anion is inert. What are the 6 strong acids? HCl, HBr, HI, nitric acid, sulfuric, okay, I'll do perchloric acid next, HClO4, and then sulfuric acid, H2SO4. Right, know those 6, know those 6, know those 6, know those 6, know those 6. Okay. All I'm going to do is give you guys I'm going to give you guys a salt formula, and you guys are going to say that's neutral or the other options we have. Acidic, basic, or neutral. How do you recognize if the salt formula is neutral, inert, and inert? Okay. What, Caitlin? You okay?
I'm just waiting because I'm on my glasses today.
Okay. What about this? Let's try this. What if I react?
Okay, I have a question. So
Mhm.
those ones you listed that are in those 2 groups will be the inert cations.
Yes.
Okay.
Yes.
And then the conjugate base is strong
And then
acid.
the anion is, you can just look for, is it the conjugate of a strong acid? And if that is your anion, then this is neutral. Okay. What about this plus this? Tell me what it makes. This is just straight up acid-base reactions. When you told me the first thing you said, say it in the right order. How do you know the Ca is what goes first? Ah, come on, you know. Well, that's your metal, right? Calcium is your cation, right? Cations always go first. Yeah, cations first. Cations first. Okay.
Calcium, S2.
Okay. Why 2? Because F is -1 and Ca is +2. And so when you put it together, that's your new formula. Okay. That is also aqueous. It will dissolve in water. And then, of course, we make water. And this is not balanced. That needs a 2 there. And that needs a 2 there. But okay. So what is the salt? I'm writing this acid-base equation to refresh practice with you guys. But I'm really just wanting to look at the salt formula. So where's the salt? What's the salt? That's my salt. So let's look at this formula. And you guys tell me some things about it. This is my salt. All right. If I look at this salt, okay, here's my cation. Came from there, right? Here's my anion. It came from there. Am I doing the same colors? Yeah. Okay. What can you tell me about this salt? What can you tell me about the calcium cation? What's the word that we have just learned about calcium ions? Yeah, calcium is inert, right? Okay. What does it mean to be inert? Calcium ion isn't going to do anything. Fluoride. Is fluoride inert? Is it the conjugate base of a strong acid? It is not, because HF is not a strong acid, is it? HF is a weak acid. Okay. So fluoride is the conjugate base of a weak acid. Agreed? That means the ion, which ion? Which ion am I talking about? I'm not talking about calcium because inert, I said inert stuff isn't going to do anything. Okay, I'm talking about the ion, this one right here. This one that's the conjugate base of a weak acid will undergo a hydrolysis. What does hydrolysis mean? What does hydrolysis mean? Hydrolysis means it will react with water. That's right. So I am just looking at a hydrolysis for which ion? Which ion is the only one I'm concerned with here? F minus. I'm telling you guys, inert ions do not do anything. They don't hydrolyze. They don't hydrolyze. This guy will. So what does that hydrolysis look like? We've been writing hydrolysis. What does it start with? Let's start with this. F minus, right? Let's show it reacting with water, right? Are hydrolysis reactions equilibriums? Bet your hiney. Yes. You guys tell me what's getting made here. Because this is a base. How do I know it's a base? I just said it was a base. This is a base. And so it's going to accept an H+. So I'm going to make HF. And I'm going to make hydroxide ion. So what kind of hydrolysis is this, guys? Base hydrolysis. Absolutely. We are doing base hydrolysis. The ion will undergo base hydrolysis. Okay. And guess what that means? This calcium fluoride salt is considered. Guys, it is indeed what is called a basic salt. Not a neutral salt, it's called a basic salt. Because what is it going to do to the pH of the water that it's in? Make it basic. Raise the pH, make it basic. Did y'all follow that? I hope so, because I never describe it in this much detail. This is slower than I've ever gone with this, but maybe that's for y'all's benefit. Okay, what else? Okay. Nope, not quite. Almost. I'm almost ready to quit, but not quite. Because I gotta show you the what? I gotta show you an acidic one. Yes. Fine. You know Loretta is. Veronica, you hanging in though? Are we at that point yet? Yes. Okay. John, you good? Ian, you good? We got another 15 minutes in us? Let's do it. What if I have kind of tricky here. What was this?
Caffeine.
My caffeine. What is caffeine? Caffeine is a weak base. Okay. I need a new color. Let's do this. So what if I add some acid to it? And let's say I add hydrochloric acid. This should be simple. Okay. Let's say I add hydrochloric acid. What am I going to make? What would be made?
H, all of that mess.
Okay. This is a good example to do because this is going to illustrate a point. With these equations, it's not always so obvious that there's water being made as well, but there is. Okay, but there, I know. Just here's what I want you to know. You guys know this is a base, and you know this is an acid, right? Is this a strong acid? Okay. Again, my focus in this chapter, in this section, is actually not for you guys to write these acid-base equations yourself. I'm doing it here to illustrate what's significant about the ions, okay? The point in this chapter is going to be looking at the formula of a salt, okay? So I'm telling you that if I mix these together, here's the salt that I would make, okay? Okay. And this is what the formula would look like. Isn't it C8?
Isn't it?
Caffeine is C8H10N4O2.
Well, your pen was saying it.
Oh, I understand now. That is an 8. Sorry. And that is an 8. Okay.
So why did you put the H at the end? Does it matter?
No, no.
Okay.
You're gonna see it like this. This is how you'll see it. Okay. And then I would actually like pop that in little brackets to show that's my cation. And then I would put my anion. What's my anion?
CL.
Good. Chloride. Okay. Cl.
What? You don't put a positive sign? You just add it?
Well, this is my cation and this is my anion, right? I'm writing the formula.
Oh.
This is the salt. That's what I'm telling you guys. I'm showing you guys what the salt is right here. This is how it looks.
How does water get made?
No, don't worry about it. There's water in there. Don't worry about it.
So do you write it in there with it?
Do I write the water?
Yeah, like what you did over here?
No, y'all don't worry about that. Let's just look at this salt. Okay, just look at the salt. Again, this is a salt. Let's identify what we can about the cation and the anion from this salt. So my cation is this guy. Okay, does it have a name? I'm sure it does. I don't care that you know it. Okay. Where did this come from? Came from a weak base. Can I just write this instead of this?
No.
Base with the H plus added? No. Y'all are going to see that. I don't know what else to tell you. Y'all are going to see things that are just B plus acid makes this.
So yes.
Okay. Okay. BH plus is what? conjugate acid of a weak base. What about the chloride ion?
Just hanging on.
What's the word that we use for this?
Inert anion.
Good. How do we recognize chloride is inert? Strong. It is the conjugate of a strong acid, so therefore it is inert. This is not inert. Conjugate acids of weak bases will undergo hydrolysis. What kind of hydrolysis will it undergo? You guys are catching on. So proud. Maybe I'm not mad at you anymore.
Why are you mad?
Test. Yeah, now I'm proud of you guys. Yeah, this is putting me in a good mood to go home and think about how many bonus points to give you guys. Yes. It will undergo acidic hydrolysis. What would that equation look like? Okay, again, I'm on shorthand. There's the conjugate acid right there, BH+. That's my conjugate acid, yes? How does it interact with water? It is going to give a proton to the water, leaving now just the base. And the hydronium ion. So this salt, a salt made of a conjugate acid and an inert anion, is a what kind of salt? Perfect. Perfect. Very good. Now what can you do with this information? Homework. How about some ice tables? You guys, oh my God. Oh my gosh. I'm not going to do that today. I'm not saying that you don't need to go home and do it. I'm saying that I'm not going to do it here with you today, but let me show you. If you want to look at how to use salts and equilibriums, you guys already know how to do ice tables. You just have to know what is the equilibrium you're writing. If I give you a salt formula, for example, if I tell you here's a salt, here's an ionic compound, sodium acetate. Sodium acetate. Can you recognize that the sodium ion is inert? Can you recognize that the acetate ion is the conjugate base of a weak acid? That means acetate will have a base hydrolysis. That would be the equation you would write at the top of your ice table. Yeah? This is where we'll pick up officially tomorrow, but guys, I think y'all ought to maybe try to practice it yourselves this evening. Okay? I think you'll be happier with yourself tomorrow if you have tried to practice some of these. I don't care if you get it all the way right, or if you at least try it and then you're like, shit, I don't know how to do this. Okay, but I think you'll be happier with yourself if you at least try. So this is number, what number did I say on it? 4. 4 and 5. Give it a shot. 4 and 5, give them a shot. Let's just see. Okay. Maybe even 4, 5, 6. I don't know. Just look at them. Okay. So
we do, like, we figure out, like, if it's acidic salt or if it's a basic salt.
that could be its own question. Or then the question could further expect you to calculate the pH. If you're calculating pH, that means I have to give you enough information to fill out an initial, right? And do your subtractions, right? It means I also got to give you a what? A K value, right? I got to give you a K value. And you are trying at the end of the day to solve for X, like we practiced earlier.
Okay.
Yeah. So your homework, first homework says due tonight. Okay. I'm willing to answer questions. I know Catherine said you all want to ask me any questions about that. That's fine. Second homework set, I will open because it has this stuff on it. I don't know the due date yet. I'm just going to put a due date of Monday night. I don't think we should, I hope, I don't know. We'll see. I'm going to put a due date of Monday night. That's what I want to say. But don't like wait till this, like, let's go ahead and start trying that homework set, the second set. Yeah, the second set. I'm going to, if we're going to have the test Tuesday, then the quiz would be open over the weekend and due Tuesday morning. So we'll just see how far we get tomorrow because it's probably, no, I only did 2 sets for this 14. Yeah, we're not going to do lab today. Not yet. I'm going to just set it. I'm going to set the due date for Monday. That's what I'm going to set it for.